In this video, let us talk about casting and type conversion. Now let us create a new variable of byte data type. So name it as weight and set this to 25. And then let us create an integer variable. So int new weight and store into it the result of multiplication of weight with 3. And let us print the new weight to the terminal. Now here we are multiplying a byte with an integer. So what do you think will be the output for new weight? So let us try this out. So javac basics.java, java basics, and you can see we are getting 75 as the output. Now let us understand how we got to 75 by understanding what happened under the hood for this expression. Here we are dealing with two different types of values. One is a byte and the other one is an integer. Now one of these values should be promoted to other types so they are equal. Now we had learnt in one of the previous videos that a variable declared using the byte data type takes 1 byte of memory, and we also know that an integer variable takes 4 bytes of memory. So any value that can be stored in a byte variable can also be stored in an integer variable, right? Now this is known as implicit typecasting, where the conversion happens under the hood by itself, or you can also say type promotion. Implicit means the conversion happens automatically without having us to do it manually. So here the weight, which is of byte data type, implicitly gets converted to an integer. Then you multiply an integer with another integer and you get the final result as an integer, right? So in essence, byte can automatically be converted to short can automatically be converted to an int can be automatically converted to a long. So any data of shorter data type can be converted to a data of longer data type. So we can say byte can be converted to short can be converted to int can be converted to long. Now let us consider one more example. Suppose we have a floating point number. So let me use the double data type for this. So double floating point number and set this to 45.33. Now suppose I want to add 5 to this number, and let us store this in an integer variable. So integer result floating point number and add 5 to this. Now from what we have learned till now, what do you think, this will work or not? So here you can see we are getting a message which says type mismatch, cannot convert from double to int. This means that here we are trying to add a double to an int, which gives us a double, and we know that a double is of 8 bytes in memory. So we cannot store that in 4 bytes of memory, right? So double being 8 bytes in memory cannot be stored in a variable of integer data type that takes only 4 bytes of memory. So in this case, we cannot demote our data type from double to int, right? Now in order to rectify this, we can change int to double, and then if we print the result to the terminal and give this a try, you can see that we are getting the correct output, which is 50.33. So as a small summary, this means that an integer data can always be stored in a double variable, but vice versa is not true. So an integer variable will get implicitly typecasted, or you can say type promoted to a double. So in this case, we have a double getting added with an integer. So our integer 5 gets implicitly converted to a double. So this gives us 5.0 under the hood, and 5.0 gets added with 45.33, and this gives us 50.33, right? So our final output is of double type instead of int. So to conclude, implicit typecasting will happen when there is no chance of data loss, which means that a data or shorter type can always be safely stored in a variable of larger type. So a short or a byte type can always be converted to an integer variable, but vice versa is not true. Now consider a scenario where we want the final result of the addition of the floating point number with 5 to be an integer. So what can we do in this case? And the answer to this is explicit typecasting. Now since we want our final result to be an integer, let us declare a new integer variable and name this as result. Now because we want our result to be of type int, so we are declaring the result2 variable using the type int. Now here we don't want the implicit typecasting to take place. So floating point number. So what we can do here is that we can demote the type of the floating point number to an integer by explicitly specifying so. So right before the floating point number, let us add a pair of parentheses. Within it, specify the type to which you want to demote it, which in this case is integer. So our floating point number, which is of double type, will now get demoted to a data of type integer, and to this integer we add yet another integer, which is 5, and when two integers get added, the final result is also an integer. So let us print the result to the terminal and give this a whirl. So javac basics.java and java basics. So now you can see we are getting 50 as the output. So what happened here is that 45.33, which is our double type, gets explicitly typecasted to an integer. So we perform type demotion from a double type to an integer. So this gave us 45 for this data. Then 45 got added with 5, we got 50, and then 50 gets stored in the result2 variable, which we get in the terminal. Now this explicit typecasting can only happen between compatible types. So here in above examples, we were dealing with numbers, and hence they are compatible with each other. But we cannot cast a string to a number because strings and numbers are not compatible with each other. So this was all I wanted to cover in this video. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, and let's catch you in the very next one.